Hello and welcome back to another VMK in the game development series. In this VMK I'll be showing you how to create 3 classes, and all the classes will inherit from our main class called NodeLight. So the 3 classes we'll be creating is the point light, the directional light, and the spotlight. We left off by having the following structure here. We have in our scene lib we created a NodeLight.cpp and a NodeLight.h. Now we're going to add a new .cpp and a .h file for the point light. So let's start off by doing that. Click on scene lib, right click and select add new item. Under header file we're going to type in here NodeLightPoint. Click open and just repeat that for the CPP file as well. Now we'll start off with the .h file. At the top we need to include NodeLight.h since this class NodeLightPoint is going to inherit from NodeLight. So we need to know what a NodeLight is. In the public members we have the constructor, which takes a graphics render type. It has a virtual destructor, it has a set position function and a get position function, and it also has a set attenuation and a get attenuation. All the set color commands are inherited from NodeLight. Now if we take a look in here, we can see NodeLight has get ambient color, get diffuse color, get specular color, and all these other functions. Since we're inheriting, we will have access to all of these function calls from within NodeLightPoint. So that's all okay. And then at the bottom here we have the render function, which takes in a counter for the light. Now this is very important. We need to define this render function, because if we didn't, then the compiler would give us an error. Since NodeLight is a pure virtual function, we can't actually use it unless we use one of its inherited members. So we need to remember to include this render function here. You'll notice that there are no member variables within this function, and that's because all the member variables come from our inherited parent here, NodeLight. So we'll be using all of these parameters here in our own class, but they're coming from our parent, not from ourselves. So that's what the NodeLightPoint.h file looks like. Now let's go implement it in the .cpp file. At the top, we need to include NodeLightPoint.h as well as the precompiled headers, and then we have our constructor. Now in our constructor, notice what we're doing here. We're calling our constructor with graphics render, and we have our render called render here. However, there's a colon and then we call NodeLight bracket renderer. What this does is it takes this constructor, gets the value for renderer, and then passes this render value into the constructor of NodeLight. We do this with the colon so that renderer gets passed into the constructor of NodeLight at the appropriate time. We can't do it inside this brace over here because NodeLight will already have called the default constructor, which would have been NodeLight with no parameters passing in. But since we didn't define that default constructor, we need to do it this way with the colon. Now inside our constructor we're setting our light type to be a point, and we need to set the last parameter for the position to be equal to 1.0. Based on looking at this last parameter in the position, OpenGL then decides how to handle the position parameters, the direction parameters, and so on. And you'll see this in a little bit. The last thing we do in the initialization is we turn the light to be on. Now you'll notice that this is a little bit of a conflict with the NodeLight constructor. If you look here, we set the NodeLight to be a point light source, but we set it to be false here. So how do you know whether the light's going to be on or off? Well, what's going to happen is this constructor is going to call this constructor, NodeLight. So it's going to go in here and initialize all these values. So initially it's going to be off. But as soon as it finishes with the NodeLight constructor, it then goes and starts running through here which means that NodeLight gets turned on. So the order that these constructors get called in are the parent constructor gets called first, and then the child constructor, which is this one, gets called second. And the same thing with the destructors. With the destructors, it works in reverse. The destructor for the child gets called first, and then the destructor for the parent gets called second. So just something to remember if you get a little confused as to which way things are happening. The destructor for NodeLightPoint is the same as NodeLight. We don't do anything, so it's just blank. We have a setPosition function call here, which we use to get a vector of 3 values, and the position in this vector contains 3 values for the x, y, and z coordinate. So we take those 3 values and we store them into the first 3 values in our member variable, which holds the position. Notice that the last parameter we initialized up here in the constructor. GetPosition returns the position of the light. However, it doesn't return a vector. Instead, it returns a pointer to a floating point value. And the reason why we do this is because OpenGL, when it does render calls, it uses an array of floating point numbers. It doesn't use our own vector class. So that's why I ended up creating a pointer to a floating point number here, so that it's easier to handle things in OpenGL. And the function returns the address of the very first element in the position array. The next function, called setAttenuation, is used to set the attenuation for the point light source. And for the attenuation, there's 3 parameters you can play with. There's constant attenuation, linear attenuation, and quadratic attenuation. By default, we're just set it to be using constant attenuation, which is the first parameter. And the other 2, the linear and the quadratic, are set to 0. You can set them to different values if you like. However, if you're using linear attenuation or quadratic attenuation, you will be using more processor power to calculate the light attenuation. If you're using constant attenuation, it's not as bad. So again, we're passing in 3 values using this vector, and for each of the values, for x, y, and z, I check to make sure whether the value is valid. Valid values are only greater than or equal to 0. So if you pass in a value that's less than 0, then I automatically change it to be equal to 0 for each of the 3 elements. And then I take those 3 elements and I just set them to the first 3 values in the array for the attenuation number. The getAttenuation returns a pointer to a floating point in the same way that we did the position. It just takes the address of the attenuation array first parameter. The last function call that we have is render. And what we do here is we need to pass in which light we would like to render. So the light number here gets passed in. And if we're using OpenGL, get the light ID number by using the constant light 0 parameter that OpenGL gives us, and we add to it that light counter. So if we pass in 0 here, we're using light source number 1. Okay, let's test this now to see if we can compile it. Okay, that compiles alright. So that's pretty much all we needed to do for the point light source. Now let's go and create the directional light. So we can close all these, and again, we're going to need to create new .cpp and .h file for the directional light. So we'll right click, go add, new item, NodeLightDirectional. And we'll do that again for the .h file. Oh, we did the .h file with .cpp file. Okay. So let's start with the directional .h file. We'll notice that there's a lot of similarities between all of these child classes that are inherited from the NodeLight. Take a look here. We have our class, which is inheriting from our NodeLight. We have a constructor and a virtual destructor. This time, instead of having a set position and get position, we have set direction and get direction. And we also have our render function here as well. At the bottom, you'll notice there's no member variables, since, again, all the member variables we're using from NodeLight class. In the .cpp file, we have our include at the top for our precompiled headers, as well as the NodeLightDirectional.h. And then our constructor, we have our constructor is created the same way we did the point light source, where we take our renderer, we pass it into our parent constructor, and then after that we set the light type here to be directional, and this time we set our position to be 0. In a point light source we set it to be 1, and again we turn our light source to be on, so we set this value here to be true. Our destructor doesn't do anything, so it's blank. Our set direction takes in a vector of 3 values, so direction is going to have .x, .y, .z right here, and we pass those into the position value. Now notice something interesting here. Our direction gets passed into position. This is important because of the way that OpenGL works. For OpenGL to handle directional light sources, it looks for the direction under the position, not under direction. This took me a little bit of time to figure out because I was putting the directional vector into the directional part, but it wasn't working. So I found out after reading through MSN that the direction is supposed to actually go into the position. And the reason why it knows it goes into position is because of this value here, the last value in position setting it to 0. Okay, so that's just one thing to take note of. After that we have our get direction, which again returns a pointer to our floating point number. So we take the address of our position, not our direction, but our position, since the direction is stored in the position. And then we have our render function. And our render function works exactly the same way that our render function worked in our point light source. If we're using OpenGL, which we are, we get our light ID, we turn on the light using enable, and then we set the ambient, diffuse, and specular color, same way as we did before, and then we set the direction by passing the direction, which again is stored in the position member variable, and we pass it into OpenGL using GL position. And that's it. So that's a directional light. Let's compile that and make sure it's okay. And now we can go add our last inherited class, which is our spotlight. So again, go back into here and we'll create a new CPP file and .h file. So at the top we include our NodeLight.h, and again we're inheriting from our NodeLight. So we have class NodeLightSpot is inherited from NodeLight, and we have our constructor and our virtual destructor. And this time we have both of these functions. We have a set position, a get position, and we have a set direction and a get direction, since the spotlight can have a position and a direction. We have set attenuation and get attenuation, and we have set exponent, get exponent, set cutoff value, get cutoff value, and our render. So this spotlight has a little bit of extra work in it that we can do, and that's just primarily because a spotlight has more parameters we have to play around with. You'll notice that in our directional light source, let's go back here, we didn't have a set attenuation, and that's because OpenGL doesn't let you work with attenuation when you're using a directional light source, since a position for a directional light source doesn't matter. So attenuation doesn't matter, because attenuation is calculated based on distance from your object to distance of your light source. So I just noticed that and thought I should mention it. Okay, let's go into the CPP and implement all these functions. At the top we have our includes, and then we have a constructor. And again, constructors handled the same way we handled the other two light sources. We get a render, we pass it into our parent constructor, and then in our own constructor we set the light type to be spot, and we set the position value here to be 1. So the last value of position is equal to 1. And then our Boolean value for our light is turned on. Once again, our destructor is empty because it doesn't do anything. The set position and get position we've seen already in the point light source, so I'll just show them to you again here, but there isn't anything new here. Our set direction and get direction is exactly the same as we had for our directional light, so there's nothing new there. But I did notice here, this should say get direction. Our set attenuation is exactly the same as we saw in our point light source, so I'm just going to skim through it. And get attenuation is exactly the same as well. Okay, we can go and set the exponent value for our spotlight, and to do that we call set exponent and we pass the exponent value into here. And the valid range for the exponent value can go from 0 to 128. So we check to make sure that the exponent value is valid. If it's not valid, we make it valid by setting it to either 0 or 128, depending on what the user selected here. And then we store that exponent value into our member variable. Our get exponent just returns the member variable that has our exponent value. Set and get cutoff works exactly the same way. The valid range for cutoff is between 0 and 90, so we check to make sure that the cutoff value that gets passed into us is valid. If it's not, we make it valid, and then we save the cutoff value into our member variable. And then our get cutoff value just returns the cutoff value in our member variable. Last thing we have is our render function. So depending on our renderer, we're using OpenGL, we get our light ID number, and then we enable the light, so we turn on the light, and then we set all the attributes for the spotlight. So we set the colors, the position, the direction, the exponent and the cutoff value, and then our attenuation values. And that's it. Let's compile that to make sure it works. And that looks okay as well. Okay, so that's it for our lights. I did want to show you one other thing. If you go into MSDN library and type in GLLight, you'll find the following information. And in here you can do a little bit of reading to find out exactly what each of these values represent. So there's exponent, cutoff, attenuation, and a little description on the side here. We're using these GLLightF. We can just double check that. Under Spotlight, for instance, you'll notice in our render function we're using GLLightFV and GLLightF. GLLightF is used for just a floating point value, and FV is used whenever we pass in an array. So again, just read through here to get an understanding of what ambient and diffuse and specular and so on are used for. So you can get a better appreciation of what each of these things do. Well, we're going to play with them in detail in the next tutorial when we actually implement our light sources in our scene so that we can place them and then actually see how they affect our geometry. So we'll be able to actually see our house being fully rendered with lights, which is pretty neat. Come back for the next tutorial and you'll see that in action.